Assalamu alaikum wa rahmatullah. Welcome everyone to IE342 Quality Control. And today's lecture, inshallah, we will continue talking about the Six Sigma DMAIC process. We have talked in the previous lecture about a brief introduction about the Six Sigma DMAIC process, and we have talked about some of the tools and the objectives of the first two phases, the define and the measure. Today, inshallah, we'll continue with the analyze phase. First, when we start talk about the analyze phase, we need to know or recap some of the information and statistics regarding to the data analysis. This is very important slide, and it summarizes the type of data, whether they are discrete or continuous data, and how you deal in the analyze phase using which tools based on those data you have. If you are having or you want to measure the variation, and this is the purpose of the Six Sigma, as we said from the beginning, to reduce variation. To identify and measure the variation in the process over a time, you use those set of tools, which is the run chart, control charts, if it's continuous data, and also the run chart and control charts if it is discrete data, but it will be different type of run chart, different type of control charts. Even though they are control charts, but they are specific control charts for the discrete data, as well as there is a specific control charts for the continuous. But the name of the tools for the variation over time is the same, whether it is discrete or continuous data. And what do we mean by measuring the variation or analyzing the variation over time? For example, if you would like to measure the variation in the production line during the operating hours, so this is considered to be variation over time. On the other hand, when we talk about the variation for a period of time, that means a sample or a selected frame in the time of the operation where you would like to do your analysis. And here, when we have this type of analysis, we have to also identify whether it is a discrete or continuous data. If it is a continuous data, then you use the histogram or box plot. If it is a discrete data, then you use bar chart, pie chart, or Pareto chart. This is not limited, but this is very common to be used based on the type of data. We will talk briefly about those tools, or most of those tools, and extra more in the next slides. The bar chart, it is used when we have, as you go back to this slide, and as I said, this slide is very important. When you see the bar diagram or the bar chart, it is fall under a variation of a period of time under the discrete data. And that's why you see the representation, it is a number or counts, is not continuous data. There is always a confusion for students when they distinguish or compare between the bar diagram or bar chart, they call it, and the histogram. There is a difference between them, even though they look the same, but the histogram, it is for continuous data, as you can see, and the bar chart or the bar diagram, it is for a discrete data, which is representing the number of counts in the time frame. Another diagram representing the discrete data or attribute data, both the same mean. It is the pie chart, and I believe most of you are familiar with the pie chart, which shows the relation among the quantities or among the factor or the variable, dividing in a pie shape using the percentage of 100 divided among the variables or factors. Additional tool that used for a discrete, which is a Pareto chart. And in the Pareto, it is very important tool, and it is commonly used in the Six Sigma along with the Pareto principle or Pareto rule. There is a difference between the Pareto chart and the Pareto rule, even though they come together in terms of the name, but you can do Pareto chart without applying the Pareto rule. What is the Pareto chart? It is a vertical bar graph similar to the bar chart. For the data, shows the observations of the data. It is for also the attribute and discrete data. And what is the difference here? And when we talk about the Pareto rule, which is named after the scientist who has this theory called 80-20 rule, which is the Pareto rule, 80-20 rule. What does it mean? It means 80% of the results will come from just 20% of the action. What does that mean? An example, 20% of the workers produce 80% of the results. Also, if you are assigned to do a presentation or a project like what you are going to do for this course, and you assigned 1 hour, 100 hours working to perform or to build this presentation. The 20 hours, especially for the beginning 20 hours that you will spend, it will reflect on the 80% of the presentation, which means 80% of the presentation will be done in the 20 hours out of the 100. Now, this rule doesn't mean specifically 20 hours and 80 hours or 20% and 80, and doesn't mean there is a 30 and 70 and so on. But it shows that the amount of effort you put, usually a portion of that effort will contribute to the result and the remaining considered to be a waste. So when they apply the Pareto chart and look for causes and look for analyzing the data, they look, for example, here in the first two parts or two bars here, when the cumulative of 80% of results being found, and that will resolve the problem considering only two factors, which is A and B. So if you focus on only A and B, you are going to solve 80% of the problem. So this is the Pareto chart, one of the other tools in the analyze when you analyze a data in the Six Sigma. The histogram, it is similar to the bar chart or bar diagram, and it is the difference only it is for a continuous data instead of attribute data. The run chart, this is when we go back to the tree where is all the data branches. The run chart and the control charts fall under the green boxes here on the right side when the variation is measured over the time for over the operating hours in the production line or the service industry. So you use run chart or control charts. Again, some people confuse between run charts and control charts because they look similar in terms of the horizontal and vertical and data scattered in the middle. What is the difference between run chart and the control chart? The run chart identifies the patterns and trends in the process, but doesn't have upper control limit, doesn't have lower control limit, doesn't have center line. It is just plotting the data to show the trends. As when I'm presenting the stock market of the day, when you see the closing time for the week or for the day, if you are looking for the temperature for a month in a city, you will see it also scattered over the time, morning, afternoon, night, the next day, morning, afternoon, night, and so on. It is just scattered or pattern of data on the time horizontal and the measurements or the reads in the vertical line. Whereas in the control charts, it looks the same, but it is meant to determine the variation, determine whether the process it is under control or out of control, and it shows the mean, which is the center line of the process, and the control line. If your data is exceeding the control line, then there is a special causes or a special problems in the process, like a machine broke down or a person who was absent during his shift, and people are making lines in front of the window, and the delays been increasing rapidly. So this is a special cause because it is exceeding the control line or control limits, upper and lower. There is a difference between control limits and specification limits. The control chart shows the control limits. The specification limits, usually it is determined to be under the control limits. Otherwise, if you are exceeding the specification, then it will be exceeding the control limits. That's why your specification limits has to be within a capable process that can produce it. And for example, let's say zone A, it's just an example. Zone A, it is your specification, and the red dots, where is the control line? If you have your specification just on the control limits, that is a risk, because anytime you are exceeding the specification, that's mean you are out of control, and that process is not capable to be performed. So the control charts are used to measure the variation and shows the process variation over the time, whereas the run chart shows only the patterns and the data plotted on a run chart without variation or control limits. More information and details it will be given about control charts in the future chapters, inshallah. Today is just to show some of the tools that is used in the DMAIC process. Scatter plot to measure, one of the tools, I believe also it's been covered earlier in statistics or design of experiment, to measure the correlation between two factors or two variables. If there is a correlation, you will see them linearly. If it is positive correlation, if it is negative correlation, it will be linearly, but for the other side where it's decreasing instead of increasing. If it is scattered in the diagram, then there is no correlation between the variables, and the correlation shows the bound between the factors, whether they are depending or non-depending on each other. And also other statistical tools there are other statistical tools can do the same, but scatter diagram is one of the easy and common to use. In the analyze phase, a major tool, and this is very important tool, and most of Six Sigma project, there is no project that I have seen that didn't use a cause and effect diagram. Sometimes they call it fish diagram, fishbone diagram, because this looks like the head of the fish, and this is the bones of the fish. Some even they have the template looks like a fishbone diagram. Some they call it Ishikawa, and he's the founder of this diagram. Cause and effect diagram, it states the effect, like the symptoms. Excuse me. The effects, for example, is a person has a fever. Okay, this is an effect. The delay or the average time for processing, it is long. People is waiting over 45 minutes of the average time or the acceptable waiting time. The effect is stated in this box. Then the causes of that effect, it showed here in different categories. You are not limited with those categories, even though those are very common to be on any problem and any process, like a method, policy, in the process, measurements like readings, machine, it could be calibration, or machines you are using are causing the issues. Materials as well as the machine is similar. Mother nature, for example, disaster happens. Sometimes even emotion. People or humans are subject, or their performance sometimes is based on their emotions. So you have to consider that as a nature, and the variation it caused, it could be under falling that category as well. People, if a training is not there, salaries and so on, you can combine categories together. You can have them as this. You can change them based on the problem. What is the cause and effect diagram says, or aim, is to visualize the causes that is related to the same effect, which is related to the same specific issue. And the idea of the Six Sigma from the beginning is to scope down to the problem and find the root of that problem. And the analyze phase is the phase where you scope down and you focus on the root cause of the problem. This diagram also, as the other names I mentioned earlier, Ishikawa fishbone diagram, they call it root cause analysis. Root cause analysis because you show the symptom, al-arid, or the effect, or what is the issue, statements here in the first box, and then you show the causes of that effect categorized based on the segment of those categories. Whether methods, measurement, machine, materials, nature, or people are applicable to your case, or you may have others. But to categorize the causes help you down to then cluster the causes in a way that you can dig inside them more to find what is the reason where is those causes being appeared. And to help you with that, other tool also called why analysis. Sometimes they call it 5 whys. It doesn't have to be limited to 5, but usually the common says by the 5 why you usually get the answer. And the 5 why work on parallel with the fishbone or the cause and effect diagram to dig inside and find why those causes are appearing and why they are affecting the process. For example, why does the home finance loan application process take more than 10 working days to arrive at the decision of credit worthy? So here, if you go back to the fishbone diagram, this is similar to the method. He's talking about the method. The method is taking too much time. So he's now doing the why analysis. The why analysis, or the 5 why, you do it with the process provider, the people who's working in the process, not the customers. The response to that question was because many applications received, especially by post, which is mail, have fields that are either not clear or left blank. So the applications are many and not well written or filled. The second question usually asked based on the first response. Why do we have applications that have blank fields? Because the customer didn't fill out the details. Then the question obviously will be based on this one. Why did the customer not fill the details? Because they were not clear. Then the question will be followed by that answer, why they were not clear. Because the directions were not clear. Why the directions were not clear? Because many of the customers never read them. Why the customers didn't read them? Because the print was too small. The font used was too small. So you become, or you found the root cause. The root cause. There is a difference between the cause and the root cause. This could be cause number 13 or 7 or 8 or whatever cause. It is just a general. When you dig down with the why analysis or surveys or questionnaire, that you do it for the process provider, and sometimes you need to involve also the customers or stakeholders, as I said from the beginning, internal, external customers, to get what is the root cause. Now, this is caused why the process is taking too long to be processed. We found out the root cause was not because of many applications and lack of human resources in the post. It was actually because the template was not written in a well format or designed in a well format, so the customers felt that completely in a way that it can be processed quickly. Okay, another tool that to be used in the analyze phase is the hypothesis test. I believe the hypothesis test is being covered in statistics as well as in the design of experiment. It is very common to use a tool to be used, or statistical tools, to find the difference between the data, to consider whether they represent different distributions, or they have the same average or different average, they have same variation or different variation. If it is a continuous data, definitely the average and the variation is the check. If it is a discrete data, you check for the proportion of the defective. Now, this is also again depend on the data, if it's continuous or it is a discrete data. The mechanism of the hypothesis, usually you have a null hypothesis, فرضية, and the null hypothesis usually to say that there is no significant difference between the two groups that you measured, and the alternate, which is HA, called the alternate hypothesis, اللي هي الفرضية المكافئة أو الأخرى. There is a difference in between the group in terms of the variation, the variance, or the average, or the proportional of defective. Usually you put those in a test and then you get the result and make sure that or to do diagnose whether the null hypothesis or the alternative hypothesis were correct. The common errors that happens in the hypothesis test, I believe most of you have seen this before. It is type 1 error or type 2 error, alpha error or beta error. Alpha error, usually it is going to it says the error of type 1, it is going to say that the HA or the alternative hypothesis, it is yes, it is correct, and the null hypothesis, it is not correct. For the type 2 error, which is usually the truth is the H alternative or the hypothesis for the alternative is correct, and you make the judgment for the process that the H naught is the one correct. I believe here there is a spelling mistake, that's why it needs to be corrected for type 2 error and type 1 error, because when you reject the H naught, when you reject the H naught and the H naught is true, that is the type 1 error. And when you fail to reject H naught, when H naught is false, that is the type 2 error. It has to be corrected. So I will correct this slide here so there is no confusion to you when you conduct the analysis. Anyway, that also will be discussed in the future chapter with examples. This is one only of the tools that is used for the analysis or the analyze phase. The improve phase, it is a unique phase in the Six Sigma. And the reason for that, the improve phase is not limited to a certain set of toolbox that is like you are pulling from bar chart, control charts, like in the analyze or measure phases. In the improve phase, and this is the unique about the Six Sigma, it can carry all the methods that can improve the process. Even now, as IE students, you are learning facility planning. You can design the facility in a way to be optimizing the workflow and the process in the organization. And that can be an improved process or improved tool. You can also use ergonomic to design a product or a device that is reduce waste and reduce variation, and that can be an improve tool. So the improve phase, usually it is one of the following generating techniques. You start with brainstorming, brainwriting, benchmarking, comparing, modifying, assuming. Then you come with a solution that can reduce the process, reduce the variation in the process. You have to consider cost, because definitely the cost is the money, or the waste, it can be a form of money. So the cost is one of the factors you have to consider, and in your solution to compare your alternative solution with the exist process. Another tool can be used is the failure mode effect analysis, and this is to identify the failure mode in the product or the process, to prioritize and to order or rank the failure modes, and how you pay attention to them when they appear. To calculate the failure mode effect, or to conduct the failure mode analysis, you do the risk priority number, which is the PRN. Priority stands for priority risk number, which is equal S times O times D, and S, which stands for the severity, O stands for occurrence, D stands for the detection. If you have taken safety course, you have already should cover this part, or if you are going to take it, you will take it in detail that time. The severity means the importance of an effect on critical quality parameter. So the effect of that occurrence, of that failure, if it happened, the effect means, for example, let's say that AC is not working during summertime in the classroom at the college. This is going to affect the teaching process. If we are taking face-to-face class, especially in the summertime, it will be very hot. The severity is 1 for not severe, 10 is very severe. Now, okay, AC, if it's not working, it is very high, but doesn't mean that we cannot continue the teaching in the classroom. But if we have, la samahullah, fire in the classroom, that is definitely going to be severity of 10, because it is high severe failure, and it will stop definitely the process, and that is the severity, which is the S in the formula here. What about the O? The O is the occurrence, and occurrence means the frequency which cause the occurs. Yani, how often this could happen. We are facing, if we recall the time when we used to take face-to-face exams or classes, the fire alarm, which is usually false alarms. Some students, or let's say some people, without naming students or others, they intentionally pull the fire alarm to cancel a lecture, or maybe make a distraction in the classroom. This occurrence, it was high usually in the exams time, but the severity, since it's a false alarm, is not high. But the occurrence was considered to be, let's say, average or a little bit above the average. But if we go back to the example of the fire, la samhallah, happens, the occurrence is very low. يعني the chances to have something like that is really rare. Consider comparing to the false alarm, which happens often. Now, what about the D, which stands for the detection, ability to control, ability of current control to detect that before creating a failure mode. Oh, this is very important. How you are able to detect it before the failure happens. The failure, the fire alarm was a detecting tool for the fire to reduce the severity of the actual fire when it happens, which is rare to be happen. But the detection tool, it became as a also failure sometimes in the classrooms or the exams to that avoid students or prohibit students from focusing in the class or in the exam. Detection tool, cameras, sometimes sensors, smoke detectors, and others. This is just, I'm giving an example for something close to our environment, but detection, it can be in a different forms. Now let's go back here in the top where it's defining the failure mode. Failure mode is the way in which a specific process input fails. This means that the input fails. The effect is the failure has a critical quality parameter, cause the source of the variation that cause the process to fail. So the cause of the failure, it's a source of variation. That means the process is not performing well. The current controls is the systemized devices or tools to prevent or detect the failures. You need to understand the definitions of those FMEA. It is very famous tool. After you get the score, by the way, when for the SOD, all of them scale from 1 to 10. 10 is very high, 1 is too low. When you get the score, you for each of those categories, for every event, you multiply them together and you list all the type of failures that can happen in the process or the product. And then you prioritize what is the most severe, the most ERN number, the most PRN number, priority risk number, and then you focus on that based on the prioritize, because this means has a high severity, high frequency, and high detection. So it is very important to focus on that one, which is the one has high PRN number, and pay attention to this very important note here in the detection. The detection, then the scale 10 means the negative, not like the occurrence and the severity. The occurrence severity, the 10 is the very likely severe or very likely to occur. But the detection, the 10 means not likely to detect, because if it is likely to detect, that means it's good thing, and that will reduce the PRN. But it is the reverse, or it is the opposite. So pay attention to the detection. The 10 means it is highly not to be able to detect it. Okay. Continuing with the improve phase, a very nice tool that students also like to use it sometimes in this mini project or small improvement in their case studies. It is the 5S. It is very common, wide, and well known. Maybe this, you have seen it before in programs or trainings. 5S stands for, it is derived from a Japanese scientist, and the S is that brought from Japanese language, but then translated in English also using SS. I mean, words start with S. It stands for sustain, to sustain the process, sustain the steps. Sort, that means sort your or order your tools, your equipments, set in order. That's mean you put everything in its place or in its order. For example, when you sort them, like you see here, the stapler and the الخرامة هذه الهول maker and the batteries, you are not sorting the same category. You are having things maybe they are not related to each other. You have to put the things, for example, screwdrivers, then you sort them together. You put them in order. That means you have sections for each category to put them in order. Then you clean the place always. You have it neat and standardized. Standardized, that means you have a standard working policy. Sometimes you have seen in the manufacturing, they have yellow strips on the floor, whereas those places when only laborers who's working in that environment or in that space to be there, you are not permitted to be there. Standardize the space, standardize the desk or the working area or the work floor. So the 5S, basically it's about systemizing the process and put everything in order. This is an example only in the office, but if you put 5S examples, you will see many pictures, and the pictures will explain it better than any words. You will see it here. So this is one of the improved phase. It could happen in the organization to improve their process and reduce variation. Also, one of the improved phase tools is the process capability, and the process capability is going to be discussed also later, is to make sure or calculate the index of the process capability to verify and validate whether the process capable to perform or it's need adjustment. The last phase, which is usually the shortest phase, even though it is going to last longer than the other phases, which is the control phase. The control phase, it has the control tools, and the common that comes in the top of the control tools, which is the control charts, the process control or statistical process control. And as we said, we are going to discuss them future chapters. Here we are just demonstrating some of the tools. You have to put a control mechanism to ensure that the process is performing and the level satisfy the stakeholders as well as reduce the variation. Control tools, if you would like to have an example in reality, Sahir, that Sahir cameras are one of the control tools. When you put a system and improve the roads and put signs for speed limits, and you put the rules for the seat belts and so on, and not using phones during driving, all these, you put the policy to reduce variation. And the variation in driving, considered to be the main defect in the process, is the accidents, to reduce number of accidents. People or countries measure their sometimes driving safety based on number of accidents. So to reduce this number, reduce that defect, you put set of policies, set of steps, set of procedures to improve the driving experience and reduce the accidents. One of the control tools that, if we consider DMAIC is being implemented, let's say, just assuming, is Sahir. Sahir is monitoring the process, and now it is being also improving to detect even other violations like crossing lines without having signal using phones and so on. Now, you agree or disagree about the application of Sahir or the implementation of Sahir. This is another discussion, but I'm talking here in terms of or the point of view of a control process or control system. Control charts, as we said, it has the upper control limits, lower control limits, specification limits, and if the process is in control, you decide whether you use SPC or the design of experiment. Experimental design, by the way, it is also one of the control phase tools that is covered in a separate course, which is IE 242. And here it just shows you that if the process is not in control, or if it is in control, and if the process is capable or not capable. If the process is not capable, then you are going to use most of the time the control, the experimental design, and investigate the specification, change the process to put it to make it capable first. Then you use the control charts. So control charts are not used if the process is not capable. If your process is not capable, how I'm going to monitor it? Why I'm going to waste the time to monitor it? Is not capable mean my specification limits and the control limits are not well determined. There is something, as I said, it could be the control limits and the specification limits are aligned to each other. Then every time you are hitting the control limits, you are hitting the specification limits, and so on. So you have to make sure that your process is capable before you make the control charts implementation. Your specification should carry the control limits. So otherwise, anytime you exceed the control limits, that means you are exceeding the specification limits. All those, it will be, as I said, further explained in the future chapters when we come to the control charts. Here is demonstrating the tool, why we use it, when we use it, it's falling under which phase. As I said, from the beginning, the textbook chapter was not even, when you go to the PDF file I uploaded, you will not find the amount of information as it's stated here. Here it will help you more to identify the tool and set of tools. I will upload this file, inshallah, by tonight on the Edmodo. So it will be your reference for the chapter 2. And the textbook, it will be extra reference, is not contradicting with what we give here, but here is more information. Also, I will demonstrate to you a summary for the Six Sigma. It's a very useful summary. In 2 pages, summarize all the DMAIC process with the main activity. This is very useful, you handy, you can have it close to you. In the define, you find the objective of the project, and the measure, you understand the practice and measure the variation and the performance, analyze the root causes, improve the process, then control it. And next to each phase, it shows you the tools. Now, you may see some, they said SciPoc, it is in the define, some other they say it in the measure. This is not going to make a big difference, but at the end you have to know how to use it and you get the use of it correctly, as well as there are some other tools also to be famous in all versions of the DMAIC. They agreed that the project charter, it has to be in the define because it's like the contract of the project, as well as the team charter template, voice of customers, control charts. Usually you see them here, it never goes. It can be appear in different, in the measure phase and the control, because also in the measure phase, some people, they use the control charts to measure, but also in the control phase to control the process. In the second page, it shows you techniques, that is, or a demonstration for those tools for every step of the DMAIC. I will post this to have it handy and next to you. Also, there is another summary, present the same thing but in a different way. It shows all of them in one row, the define, the objective, the main activities, as well as the tools, and the key deliverables means that going to be the output of that phase, or the key deliverables for that phase. And it's summarized in one page. Both of them are useful. I will post both of them since it will help you to understand the DMAIC more. Now I will open the questions for you. We have enough time to discuss all the questions. For this, we can say that we have completed the DMAIC chapter, and we have covered the all phases, not all the tools. It was just briefly giving all the information can be given about them. And then in the future chapters, some of those tools will be further explained. Some others, like design of experiment, is being discussed in another course. Statistical tools like bar chart, histogram, all those being discussed in the statistics course. So here we are going to focus in other tools that is not being discussed enough in other courses. So the floor now is open for any questions. Please feel free to ask any question. You have anything that is doubt, refer to the slides that we have covered earlier. I will go back to the slides to track your questions. And then we will do also the attendance for both sections, IEA and IEB. Pay attention here. This is a small here observation that I would like to draw you back. The role of the Six Sigma usually, the duration of the project of Six Sigma usually takes long to get the results, because the control phase, it should takes about 2 to 3 months to find the result. And that's why the black belt training, it is kind of long, because you need to expose to long projects. Anyway, this is just something that I would like to draw your attention about. It's not just attending training. You have to conduct projects, a long, big project that is include most of the Six Sigma tools, and prove that to authentic organization like ASQ, American Society for Quality, and then you can apply for their exam. Okay, any questions? You can use mic, you can use chat box. While I will do the attendance, we will start with section IEA.